Hello students, welcome to my YouTube channel. I hope you people are doing good. In our today's session, in our today's video, we are going to discuss circular measures for A-levels mathematics. This is A-levels mathematics, AS mathematics, and it helps us to find out all possible things related to circle. Okay, it's area, and then we'll be discussing chord and sector and everything. So let's start. First of all, suppose this be a circle. This is known as radius of the circle. Its area is considered as pi r square and its circumference is 2 pi r. Diameter is 2r. Diameter is basically a straight line that passes through origin. That is known as a diameter. Okay. What is a chord? Chord is basically starting from a point on circle straight to the second point. This is known as a chord. This divides circle into two parts. This is segments. The smaller one is known as minor segment. The second one is known as major segment. Now diameter is also a chord that is basically passing through origin. After discussing segments, if you see this is sector AOB. Now difference between segment and sector here is segment is made by a chord that divides a circle into two parts, not necessarily equal parts but two parts, okay, and minor and major segment. Similarly, if we have a center O and suppose this is radius R, OA and OB are radii, and starting from A till B, okay, AOB, this portion is known as a sector. Okay, this AOB is known as a sector of circle. Obviously the smaller one is known as minor sector. The bigger one is known as major sector. Okay, after this, if you see, this is arc AB. Okay, this is the minor arc, and ACB is the major arc. OAB, this is a sector, and this is the arc. This portion is an arc. So we say, okay, here it is, AB is an arc, right? And this is chord and diameter and all that. So after understanding the difference between sector and segment and arc, let's introduce couple of formulas that will be using it. Okay, now these all are the formulas. Suppose area of a triangle, it's 1/2 AB sine theta. Area of triangle, 1/2 AB sine theta. You can find out my previous videos on these topics, especially on area. Parallelogram, and then we have a trapezium, 1/2 into height into sum of parallel sides. Sine rule, cos rule, and all these formulas will be needed in this chapter. Okay, now let's start. With circular measure, first of all, we discuss definition of a radian. So before that, what we've been doing was angles. We've been measuring angles in degrees, right? But now this is new definition, that is 1 radian. Okay, suppose this is center O and this is A. Starting from A, if you move on the circumference till point B and you cover the same distance of the radius, at that instant angle subtended is known as 1 radian. Or when radius becomes equal to arc length, angle subtended at the center is known as 1 radian. I repeat, this is OA, that is radius of the circle. You start from A, move on a circumference till a point where your distance is equal to that of the radius. At that instant, angle subtended at the center is equal to 1 radian. Okay, so you would say that when AB arc becomes equal to radius, angle subtended at center is 1 radian. So let's discuss couple of more examples related to this. Suppose we have these circles given. Okay, so in first case, if we assume that this is 6 centimeter OA, okay, so on A to B you move on circumference of 6 centimeter if this radius and arc length are equal, at that instant this angle is equal to 1 radian. Suppose we have another circle, this is of 10 centimeter radius, it's O and A. So you start moving on circumference such that till B you move 10 centimeter on circumference, the arc length is 10 centimeter. At that time this is equal to 1 radian. Similarly, suppose we have a circle of 8 centimeter radius, so you move from A to B, it's 8 centimeter radius. If it is 8 centimeter, at that time angle subtended at center is known as 1 radian. So definition of 1 radian is when the circumference becomes when the arc becomes equal, the arc length becomes equal to the radius, this is known as 1 radian. Okay, so let's discuss one more case. Suppose this is a 12 centimeter radius circle, you move on the circumference of 12 centimeter, at that time angle subtended at the center is 1 radian. I hope definition of 1 radian is clear, right? Okay, for example, now we are going to have a comparison between degrees and radian. Obviously, when we are going to discuss a new unit, we need to know what is comparison between degree and radian. We will need to convert angles from degrees to radian and back from radians to degrees. So for that, have a look how can we compare degrees and radian. Now we believe that on a straight line angles in degrees is equal to 180 degrees. Okay, so what we did initially, we started with finding the angles. Suppose this is 1, 2 and 3. So on a straight line, if we start, it's O, it's A, this is radius. Okay, so 1 radius, if you move till this is equal to 1 radian. Similarly, if this is radius, we move further, this is also 1 radian, this is 1 more radian. Okay, when we do it, we try to do it 4th time till E, it surpasses 180 degrees. So after calculations, after careful calculation, we found that this is 0.14 something. So on 180 degree on a straight line, this was equal to 1 radian, 1 radian and 1 radian and 0.14. So it was something 3.14 radian. Okay, after careful calculation, this was equal to pi radian. So 180 degrees is equal to pi radian. Okay, at this point, this is the thing you should remember, that 180 degrees equal to pi radian, and again this is also pi radian. So 360 degrees is equal to 2 pi radians. Now you need to keep this thing in mind. Whenever we need to conversion, we need to find conversion between radian to degrees and back from degrees to radian. This is thing we are going to use. 180 degree is equal to pi radian. At this point, before we move on, I just want to discuss one important thing. Value of pi is 3.141 something, and it is a ratio of circumference. It is a ratio of circumference to diameter of any circle. So pi means a ratio, that is circumference of the circle to the diameter. Now after this, let's have some examples of conversion. So convert into radians. So first of all, for instance, we need to convert 60 degrees into radian. So what you will say is 180 degree is equal to pi radian, 60 degrees will be equal to x radian, and you can simply cross multiply it. Okay, 180 degrees is pi radian, 60 degrees is equal to x radian, so it is 180x is equal to 60 pi, so it is x equals 60 divided by 180 pi, so that is equal to pi by 3. Similarly, for example, we have 180 degrees is equal to pi radian, and if I want to find out what is value of pi by 6 radians in degrees, so you simply cross multiply it. 180 into pi by 6 is equal to pi x, you can cancel this pi, and it is 30 degree, so that is equal to 30 degree. This is how we find out how can we convert from degrees to radian and back from degrees radians to degrees. Okay, for example, we are going to convert the following in radians, and this is 60 degrees. We need to convert 60 degrees into radians, knowing that 180 degrees is always equal to pi radian. So we will be doing cross multiplication. It is equal to 60 pi equals to 180x. So it is 60 pi divided by 180. So it is equal to pi divided by 3 radian. Okay. Secondly, it is in second question, we have to convert 30 degrees into radians. So if you see, this is 30 pi is equal to 180x, so it is 30 pi divided by 180, that is equal to x. So x is equal to pi divided by 6 radians. Okay. Similarly, 45 degrees we need to convert. It is 45 pi is equal to 180x. So x will become equal to 45 pi divided by 180. So x is equal to pi divided by 4 radians. So that's how we're going to convert from degrees to radians. Now let's learn how to convert from radians to degrees. Okay, we'll be using the same conversion technique, and let's suppose they say convert from radians to degree. We know that pi radian is equal to 180 degrees, right? So suppose I need to convert 2 pi by 3 radians into degrees. So you cross multiply it. It's pi x is equal to 180 into 2 pi by 3. You can cancel this pi, and this is equal to 120 degrees. Similarly, for instance, you want me to find to convert, it's always pi radian is equal to 180 degree, and they say find what is 3 pi by 2 into degrees. So again we cross multiply it. It's pi x is equal to 180 into 3 pi by 2. So pi is cancelled out with pi, so it is 270 degrees, right? Okay, now let's discuss what is area of sector. So area of sector is basically 1 by 2 r square theta. You need to remember one thing, that all calculations must be in radians in this chapter. Okay, so for instance, we have a circle. Suppose we have a circle with radius 6, and let this angle be 30 degrees. So this is 6, it's O, A and B. So we will be using pi by 6 degree radians. So its area is equal to, area will become equal to 1 by 2 r square theta, that is equal to 1 by 2 into 6 square into pi by 6. So you can simplify it, and it is equal to 3 pi centimeter square. Okay, Okay, now let's discuss about arc length. Suppose this is OAB is a sector and we need to find this arc. The length of this arc, the arc length is equal to S is equal to R theta, okay? Or in some books we also discuss it, L equals to R theta. So this is known as arc length. For example, we have a circle with radius 6 and this is pi by 6. It's OAB and we need to find this arc length. So arc AB will become equal to S is equal to R theta. Okay. So arc length is equal to radius is 6 and theta is pi by 6. That is equal to pi centimeter. That is basically arc length of this sector. Okay.